Hello. Today we're going to talk about the latest generation of semiconductor equipment data communication standards and the impact those will have on future factory systems and manufacturing capability. When I say the latest generation, what I really mean is these standards have actually been around for the last 10 years, but are only now seeing the kind of adoption momentum that will have a major impact on the industry. The standards I'm referring to are the so-called Equipment Data Acquisition Standards, or Interface A. There's a whole long list of SEMI numbers that those constitute, but we'll get to that in a different discussion. The key difference about those standards, though, is that they address some of the biggest challenges that we've faced in collecting data to this point. Now, we've been collecting data for 30 years in this industry, so that's not really the issue. But the problem has been that the data that's available from a piece of equipment is not well documented in any place. It's either in a specification or a spreadsheet or in some equipment integration person's head. And whenever you have multiple versions of something, at least two of them are usually wrong. The other issue is that the architecture for these systems has been very rigid. The typical architecture is a point-to-point communication, such that a piece of equipment can have one and only one consumer of that data. Now, there are certainly ways of getting around that in modern factory systems, but that's still a significant limitation. The final one is that once a data collection scheme has been defined and put into an equipment integration server, it's fairly rigid. And if a process engineer has demands for new data on the fly, it's very difficult to incorporate those without waiting days, weeks, or months to get those data collection schemes modified. The EDA generation of standards address all of those challenges. First of all, the information about what's available to be collected from a piece of equipment, the parameters, events, alarms, state machines, all of this is actually captured in an integrated model of the equipment that the equipment stores and makes available for upload. Secondly, the data collection scheme is determined by user-defined data collection plans, which can be defined at any time on the fly. And so if a process engineer comes up with a new requirement, all that person needs to do is edit or create a new data collection plan, validate that on the equipment, enable it, and then you have data flowing. The final point is that the standards support multiple independent client access, so that the data can be delivered to a variety of applications without knowledge of one another. So it's a much more capable set of standards for supplying data on demand to the consuming applications. Now, in a way, it's like thinking of the media world and how the significant evolution we've seen there. If you compare let's say 15 years ago, when you had a television with 3 or 4 major networks with fixed programming, you had one place to watch, you had 3 or 4 shows that you could see, and you were not in charge of any of that, other than picking among that 3 or 4. Today you have many sources of media, you have thousands of choices available at any given time, and you can watch those on a variety of fixed or mobile platforms. So this is really the analogy of the difference in today's communication scheme versus what we've had today. Architecturally, the good news is these standards don't actually conflict with the existing factory systems. So in the diagram you see now is a typical hierarchical factory control system with an equipment layer supplying data, an equipment integration layer that communicates directly with that equipment, and then an application layer that utilizes that data and provides the commands. That architecture can be completely preserved when you add an EDA infrastructure. The interfaces are separate in the equipment. They use a separate set of networking technologies and can be distributed either within the factory, across the company, or even across the globe. So there's no disruption to the current factory system environment by these new standards. So in later presentations, we'll get into the details of how all this actually works. But for now, I just wanted you to understand why these things are different at the high level and why that's important to the industry. Thank you.
Next one.